All right, so we're going to do our last topic, which is in Chapter 7. It's on logarithms. We'll do sections 7, 2, 3, and 4. First, I just want to start out with basically where you would see a logarithm used. If you had an equation like that and you wanted to solve it, any equation that has a variable in it, where the variable is an exponent, you could use a logarithm to solve it. Now, this is simple enough. I think most people could guess 2 to what power would give us 8. What would that be? 2 to the third. Yeah. That one's not too hard. We can kind of figure out the answer because 8 is a power of 2. So you can do it in your head. How about if I did, let's say, one like that? 3 to the third would give us 27, but 3 to the second, yeah. Okay, again, not too bad to figure out because 9's a power of 3. Now if I just change it a little bit, just change a 9 to an 8, now it becomes a little harder to do in your head. Well, 3 to the third power, 3 to the second power is 9. That's too big. Okay. 3 to the first power, that's 3. That's too small. So the answer is somewhere between 1 and 2 for x. Okay. Maybe 1.6, maybe a little higher, maybe 1.8, 1.9, somewhere around there. But we could figure out exactly what it is with a logarithm. Okay. So by the end of the week, hopefully you'll know how to figure that out. So first thing I want to just explain is what these all are. These are all examples of exponential equations. And if we just focus on, say, this left-hand part, 2 to the x, 3 to the x, those are called exponential expressions. Any expression that has a variable as an exponent. Any expression that has a variable as an exponent is an exponential expression. And I put a couple examples, 2 to the x, 3 to the y. Where you might see a problem where you had a variable as an exponent, if I said to you that I'm going to give you $10,000 to invest in a savings account, making 1% interest, how long before you would have $11,000? So if you just let the money sit in the bank and make interest, how long would it take for you to make $1,000 in interest, basically? That'd be a problem you'd use a logarithm to solve, okay? Solving for how long it would take. Okay, and to solve, let's change that to an equation. Once you take an expression like this, put in an equal sign, and put a number on the other side, now you've made it into an exponential equation. Okay? Equations have equal signs. And to solve it, we're going to change it into what's called a logarithmic equation. Right, so we're going to be converting between these two types of equations, an exponential equation, which looks something like this, and a log equation. And there's a formula for how we change one to the other. We'll practice a few examples. There's really 3 basic things. You've got this, this, and that. And when we rewrite it, we just have to figure out where those 3 things move to. They just move to different spots. Okay, so on the left, this is something in exponential form. Like 2 to the x equals 8, like we had before. On the right, I've rewritten that in log form. So we just got to kind of figure out where the a, the y, and the x all move to? First thing I'll start out with is the a. Okay, when you write a number below an exponent like that, the y is the exponent, and the a has a name too. It's the base. Well, the base, think of the base as the thing that's always the lowest, right? The base, okay? It supports everything. So here, the a, that's written a little bit lower than the log. In fact, I'll show you if you had lined paper, how you would write this on lined paper. Okay? So a is your base on the exponential. A becomes our base, the thing that's lower, next to the word log. Okay, next thing we want to figure out is where the y goes. Okay, I just said it earlier, but what's the number that's written higher than the base? What's that called? That's your exponent. Okay, well, when you're using a logarithm, the logarithm always equals the exponent. So when you write something as a log, the exponent always goes by itself. Okay, in fact, let me write that down. Logarithm always equals the exponent. So, look at what your exponent was. Take the logarithm, have it equal the exponent. If you can figure out where 2 out of 3 things go, there's only one thing left. There's that x, and there's that spot right there. Okay, this is called the argument. The argument is just the thing that gets plugged into something. Okay, that's all it is. We've seen arguments all year with sine, cosine, and tangent. If I wrote down like, I don't know, sine of 15 degrees. 15 degrees is the argument. It's the thing we're plugging into sine. Well, in this case, x is the thing we're going to plug into log. Normally that'll be a number. Okay, how do you pronounce what's on the right-hand side? Okay, the way you say it is y equals, or you could say y is log base a of x. Y equals log base a of x. That's how you say it. And if you were writing it on line paper, you've got log. Let's just make one up. Base 3 of 12. That's how it would look on line paper. Okay, that 12 is not an exponent. This would be an exponent. That says log base 3 of 12 to the 5th. Okay. 3 is a base, 12 is an argument. So any questions on how you write it or how you say it? And we'll talk about how you plug this in. Like if you wanted to know what does this come out to, how do you even type that in on a calculator? Tomorrow, you'll learn how to type that in. Okay, today I'm going to show you how to type some of the things in, but I'm not going to show you how to type in something that would have a 3 there. Not today. I'm going to look at something a little simpler. All right, so let's try taking an equation that's already in log form, and let's change it to an exponential equation. All right, so first thing you want to do, look at it and identify your base. Remember, the base is the number that's a little bit lower on the log. So Jose, what's my base here? 3. So we're basically going to have something like this when we're done. We've got to figure out what goes in the 3 boxes. Okay, we just got this one, 3. Now we're going to figure out our exponent. Okay, Dave, do you remember what I wrote off to the side in green? I said logarithm always equals what kind of number?
Exponent.
Good. Logarithm always equals the exponent. So what's the logarithm equal to here?
The x. Oh no, the y.
The y. Okay, this is the logarithm, this whole thing. That's the base on the logarithm, that's the argument. That whole box is the logarithm. And it's equal to y. Whatever the logarithm equals, that's the exponent. Okay, so it's 3 to the y. Antonio, what haven't I used? The what? The argument, perfect. I haven't used the argument, okay, the x. There's only one spot left for it to go. Right there. That's how you change something from log to exponential. There's nothing you can do to solve that. Okay? If you knew y, you could do it out. Like 3, if y was, say, what squared, you could do it out. 3 squared would give you 9. Okay, but we don't know x, we don't know y, so we stop there. Okay, any questions on that? Let's try this one. Mauro, do you remember how to say that? Like if you just wanted to read it off to me?
Y equals log base.
Yeah, so far you're good. Y equals log
Log base 5x.
of x. Yep, perfect. Yep, y equals log base 5 of x. So figure out your base, your exponent, and then what goes on the other side.
I have to solve.
Yep, what'd you get, Joe?
5 y exponent equals x.
Yep, 5 is your base, y is your exponent, x goes by itself, we're good. Without knowing x or y, you can't go any farther. You have to stop. Okay, any questions on that one? So that's changing log to exponential. Let's try the other way. Exponential to log. Bradley, if we're going to change it to log form, what do you think the very first thing we should write down is? Keeping in mind it's going to be in log form. Log form.
Would you start off with what? Changing from well, answer that. And you're changing it to exponential from that. We're gonna find log.
So there's something I want to write down right away.
The log.
Log. I'm going to put that word down right away because we're going to change it to log form. Log form has to have the word log in it. And it's going to have an equals as well. Now we have a place to put the 3 things. Something's going to go by itself. Something will be the base. Something will be the argument. Right, so if you wanted to put boxes to kind of visualize where things are going to go, fill in the 3 boxes. I usually start with the base. That's the quickest one to figure out. Yep.
I was just going to give it to you.
Okay, you got the whole thing? Go ahead.
3 equals log base of 1.2 of, about that, m.
M. Okay, let's go through it. 1.2 is your base. It's the number that's below the exponent. So that's the number that goes below your log. Logarithm always equals what kind of number I wrote? Log always equals the exponent. Your exponent is 3. So this time, your log equals the exponent, 3. Once you fill in those 2 boxes, there's only one box left. There's only one thing you haven't used, M. And that's it. Okay, any question on that? All right, let's try that one. e to the power of b equals 9. Yes?
Would it be b equals log e?
I'm not sure where you want me to put that e.
9. Like right below the
So you want that as your base, right?
yeah.
Yeah, so good. B equals log base e.
Is that right so far?
So far, yeah.
Okay. And then the 9 is going to go next to it.
Yep, that's your argument.
The argument.
Yep, that's the thing you're taking. You're taking the log of 9, and you're going to use e as your base. This I could show you how to type into a calculator. We'll do that later. This one's really the same as some of the other ones. It says a to the 4th power equals 24. All right, so Brett, what would be the first thing I'd want to put down? Yeah, if you're changing to log, write down the word log. Okay, Emily, what's my base? Good. Base is A. Cecily, what's going to go by itself here?
4.
Right. Logarithm always equals the exponent. What's the exponent? 4. Okay, last thing I have to fill in, Alec, is what? Yep, 24. Do you remember what this is called? The thing you're plugging into the log? The argument. Good. Okay, any questions on that? So that's how you change to a log equation. Okay, now we've done that, let's try one more the other way again. Okay, let's change to exponential. Sometimes after we change one way, people start getting confused how to go back again. So this is just like example 1. Exponential equation. Anytime you have an equal sign, that's an equation. So I think I had expression in the last one, but I meant equation.
I apologize for the interruption.
All right, so first thing is identify what your base is going to be, what your exponent's going to be, and then we'll put whatever's left by itself on the right-hand side. You want to give me the whole thing, Joe?
Yeah, e to the negative 3 equals b.
Good. Perfect. E to the negative 3 equals b. Now, we're going to talk more about e in a little bit. Okay, e is, it's not just a variable. Okay, it's like the Greek letter pi. So if you type pi, yes, pi is a letter, but it stands for something. Okay, it stands for the number 3.14. Okay, e is a letter, but it also stands for something. It stands for the number 2.718, and so on. Okay, I'll talk more about that in a second. So this is one you could actually figure out what the decimal is. You can take e and raise it to the negative 3rd power and get an answer. Okay, you don't have to do that on this problem. I just want you to start to understand. Think of e like pi. It stands for something. Has anybody ever used that number before? 2.718?
Never heard of b.
Never heard of e? Yeah, most people haven't heard of e. They've heard of pi. Yeah. You've used pi before?
Yeah.
3.14? Yeah. E's not used as much as pi. E's jealous, you know what I mean? Gets upset. People forget about it.
Kind of ugly.
You know. We won't forget about it today, though.
Darn.
We'll talk about it. Okay, so this problem is basically solve for x. Okay, and my suggestion is, right now, we only know how to do one thing. If we have an equation that has the word log in it, what can we do? Yeah, we can rewrite it so we don't have the word log. It's the only thing we know how to do. If that doesn't work, then we're stuck. Okay? But hopefully that will work. Okay, Abby, what's my base here? 2, good. Okay, Brianna, what's going to be my exponent? What is it? X. And the logarithm always equals the exponent. The only thing left, I've used the 2, I use the x, is the 16. In fact, this one I might have put on the board at the beginning of class or something very similar to it. Yeah?
I know what X is.
Yeah?
4.
4. For this kind of problem, I'll always make sure that the argument is a power of the base. Otherwise, you're not going to be able to do it in your head. Good. Perfect. Okay. Any question on that? Right, so you're just changing it from log to exponential, and from there you got to figure out, well, okay, 2 to the 2nd power, no, that's 4. 2 cubed, no, that's 8. 2 to the 4th, there we go, 16. In fact, you might be able to just look at it, and after a while you can tell the answer without even rewriting it the way we did. We'll still rewrite it, just to practice it. Anybody see the answer right away? Yeah? 2. It's basically saying 5 to what power would give you 25? 5 is your base. X is your exponent. And you get x equals 2. What mistake do you think I see a lot on a problem like this? They put x equals 5, right? Because they think, oh, 5 times 5 is 25. Yep, that's true. But it wasn't asking 5 times what is 25 here. So 5 to the 2nd power is 25. Hey, questions on that? Okay, and one more kind of on the same idea. Let's just rewrite it first, okay, and then we'll look at it. The only thing that I think might trip people up here is this fraction. Okay, 27 is a power of 3, but it's not 27, it's 1 over 27. All right. So let's start with my base. Okay, Jalen, what's my base?
3.
Yep. Base is 3. Brianna, what's my exponent?
X, sorry.
Yeah,
I
x.
was writing something else, sorry.
And then the 1 over 27 goes by itself. So let's pretend that we just have this as a problem. 3 to the x equals 27. This is not what we have, but it's going to be very, very similar answer. What would x equal in this case? Yeah?
Would it be like 1? Actually, never mind. I'm kind of screwing myself here. I never did.
Well, let's start with this one first. Dave, 3 to what power would give me 27?
Well,
It's a nice answer.
okay.
3. Yeah. So if we had 3 to the x equals 27, the answer would be 3. Problem is, we have 3 to the x equals 1 over 27. Does anybody remember what kind of number the exponent has to be to cause that to flip? It's a certain type of number.
Would the answer be like 0.33? Is that what it would be?
No, it's not 0.33.
Ugh.
It's negative what? Negative 3. Okay, anytime you have an exponential expression equal to a fraction less than 1, because you flipped it, you got to make your exponent negative. Okay, so what if you had something like 5 to the x equals 1 over 25? What would x be there? Negative 2. If it was 5 to the x equals 25, it'd be positive 2. You want me to flip it? Okay, I'll make the exponent negative. And if you get stuck, you can always check your answer. Try plugging in -3, see if it works. 3 to the -3rd is 0.037. Take 1 and divide by 27 and you should get the same thing. If you don't, something's wrong. 0.037. But you can always check your answer that way. Any question on when your exponent should be negative? So if you're looking for a fraction, usually it'll be a 1 in the top, and the number in the bottom will be a power of the base on the other side. If it's not, you're not going to be able to do it in your head. Okay, letter E. Okay, so I already kind of said this earlier because we had a problem that had E in it. But E stands for something, like pi. Okay, it's the number 2.71828. Okay, if I type E in, kind of looks like the pattern might repeat. You have 1828, 1828. You might think, oh, it just keeps going 1828. No. After that, it changes. Right, so it's like pi. Doesn't end, it doesn't repeat. It's irrational. And E generally comes up a lot when you do logarithms. Especially when E is the base. Okay, I think we might have had one similar to that earlier. Maybe example 2. Let me go back and check. We might have had a log where E was the base. Yeah, example 2b. Okay, I didn't say anything about it at the time, but this is something special. Okay, when you have E as the base. Because that's used a lot. Okay, E is a number that they use in the base quite a bit. They have an abbreviation for writing all of that. Okay, a little bit shorter way to write it. Not a lot shorter, but a little bit. Okay, lowercase l, lowercase n. So those two things that I just circled, they mean exactly the same thing. Lowercase l, lowercase n, it's just an abbreviation for what I circled up above. This is how most textbooks would write it. On your calculator, you should have a button there that says ln. It's usually right above or below the button that says log. Okay, on mine, I have log. Right below it, I have ln. So these two things are exactly the same. Log base E can all be replaced with an ln. What's x? Well, x is the thing you're plugging in. So if I did something like this, x is 5 now. It's the thing I'm plugging in. Could be anything. Anything that's positive cannot be negative. Anybody know what the ln stands for? It actually stands for something. It's kind of backwards the way we say it, but how about the L part? What are we studying this week?
Is it like non-linear? Something random like that?
No, it's a good guess though, because if you do graph these, they are not straight lines.
I know.
They're curved when you draw them. But we're not actually going to get into any sketching this week. But yep, it's a good guess. How about the L? What are we studying this week? Logarithms. Well, this is a particular logarithm called a natural logarithm. Okay, if you ever have to take a logarithm and the base is e, that means someone's asking you to find a natural logarithm. There's only 2 logarithms that have special names. This is one of them. Okay, when the base is an e. And it's one of the 2 logarithms you can directly type in on the calculator. Okay. If you wanted me to find the natural log of 5, I can press ln 5 and hit enter. Let me show you what happens if I type it in the long way. Okay? It's equivalent. I should get the same thing. I'll show you how you type that in. You don't have to know how I just typed it in on there, because I'm going to teach it when I teach it in a way that you don't have to have this kind of calculator. Just makes it very easy for me to type it in fast. You do not need that. All right. So my point was to show you get the same thing. Okay. Any question on what a natural log is? That's the whole key right there. The base is e. You have to be careful when you write it as ln, because a lot of times people start to forget what the base is, because the base is hidden. Notice when you write ln, you don't write e anywhere. The e is hidden in the abbreviation, so you have to remember that. Okay, so this one I want you to change to an exponential expression, just like we did before. So we have to identify the three things. Figure out your base, your exponent, and what's going to go on the other side. Okay, what's my base here? E. It's hidden and you can't forget that. It's not written. Everything else you see here, the x and the 8, there's going to be spots for those to go. But you've got to remember that E is the base and it was hidden. E is my base. My exponent. Jose, what's my exponent?
I'm sorry, I wasn't paying attention.
What's the long way to write this out? This ln?
It is
8.
8.
Yeah, because if you think of this as log base e, this is just a logarithm equals the exponent. Specifically, it's a natural logarithm, but it's still a logarithm. Okay? Logarithm always equals the exponent. And then x goes by itself. So if they wanted, this is something you could type in. Make sure on your calculator you know how to type that in case I ask you to round it off. This is kind of big. Probably wouldn't have you type that in. But if they did want you to, that's how you do it on my calculator. Press second. I have a button for E. And then I put in the 8th power. Any question on that? Okay, so don't forget, when you see ln, the E is hidden. So this one's pretty much the same thing. We can go through it. Okay, Brett, could you give me the whole thing? My base, my exponent, and what goes on the other side? Or maybe just the base. Let's start with that. E is my base. Good. Okay, Antonio, how about my exponent?
12.
Yep. Logarithm always equals the exponent. X is the only thing that's left. Any questions on that? This is starting to get really big, probably in the hundreds of thousands. I wouldn't have you do that up. Just leave it like that. Okay. And the last type of logarithm that has a special name, it's called a common log. Okay? Common log is when the base is 10. That's an example of a common log. Log base 10 of 5. Okay, so if I ask you on the test to define what a common log is, you'd say it's a log that has a base of 10. If I ask you what is a natural log, it's a log with a base of e. So there's one common log. There's an example of another common log. What's a pretty big difference in the way I wrote those, besides the exact numbers I used? What do you notice about the second one versus the first one? Yep.
There's no subscript.
Yeah, there's no base written there. Okay? If you don't put a base on a log, it's kind of like in algebra if you just write a letter and you don't put a number in front of it. There's something that's assumed to be there even though you didn't put it. Okay? Well, with a log, if you don't put the base, we assume you want common log. Base 10. So in most textbooks, anytime they're working with a logarithm and they don't put a base, that's because the base is 10. You do not need to write it if it's 10. If it's anything else, you do need to write it. Or if it's a natural log, use ln as the abbreviation. Okay, any question about what a common log is or how you write it? I'd prefer you to just write it the way I did the second way. Log 40. And you can type this in on your calculator. So if you wanted to know what the log of 40 is on your calculator, just press log 40. Okay, I like to close the parenthesis, especially if you have something else you're going to type after it. If you don't, it doesn't really matter. That's the log of 40. Yes?
Before when you were doing that and you were putting in the base, you pressed a different key so that it gave you the two numbers.
I did, yes.
Would you need to do that to account for a common log, or does it just not matter?
No, I could type it in that way. It's going to take me a little longer. But I'll get the exact same thing.
What if you just put nothing in the base?
It'll give me an error.
Okay.
I don't think it'll, if you tell the calculator, hey, give me a spot to type something in, and then you say, wait, I'm not going to type in, and it's probably going to get upset with me. Yeah, it gives me some kind of error, even if I put in the correct number. Yeah, it's giving me an error. Yep. If you don't have a calculator that allows you to type in, like I am right here, don't worry. You don't need it. There's a way to type in something with a different base without that fancy formula. And I can type it in just as fast without using this fancy formula as somebody could using it. This doesn't really save me any time. Okay, but that'll be tomorrow. All right. Any questions on common log? All right. So we'll finish up with 3 examples solving for x. Okay, logarithmic equations don't really get any more complicated, the ones we're going to do, than Algebra 1. So as long as you know how to solve multi-step equations from Algebra 1, I would make sure you know how to factor. That's not going to happen in this problem, but tomorrow that'll happen, factoring, and possibly quadratic formula. I would say generally factoring will be sufficient. Everyone knows what I mean by factoring? Like something like this. Factoring. That's for tomorrow. All right, so we got an equation. We're trying to solve for x, and it's got a log in it. It's the only thing I know how to do with that. Well, this argument, we can't do anything to it. It's kind of like if you had this. You can't add or subtract anything from x yet till you get rid of the thing that's protecting it. So right now, this log is protecting that entire argument. Just like this square root would be protecting everything under it. So the first thing we have to do is get rid of log. What do we call that when we change it from log form to, yeah, we're going to change it to exponential. Okay, you have to change it to exponential. It's the only way to solve it. Now, I agree, if you didn't have that log there, and it just said 4x minus 7 equals 2, then yeah, sure, add 7 to both sides and then divide by 4. The first thing we got to do is get rid of that log. Okay, Brad, what's my base here?
3.
3, good. 3 is my base. Jess, what's my exponent?
Wouldn't it be the 4x minus 7?
Well, the 4x minus 7, that's my argument. So remember, the logarithm always equals
The exponent.
the exponent, yeah. So in this case, the exponent is just the 2. Okay, so whatever, when you have a log, whatever's by itself on the other side, that's the exponent. And Cicely, what's the only thing I have left?
The 4x minus 7.
The 4x minus 7. 3 is my base, 2 is my exponent, 4x minus 7 goes by itself. And now we solve it. Okay. Emily, what do I do first to solve that? Square root? I don't think we need a square. We are going to use a square root in the next problem, but not for this one. Even before you add 7, I agree, that's a good step. But let's add 7 next. There's something I would simplify first there. Yeah, the exponent. How do you simplify 3 squared? 9. There's no reason to leave something more complicated than it needs to be. 3 squared, just write that as 9. Now we'll add the 7. Okay, negative 7 plus 7 cancels out. 9 plus 7 gives me 16. Eliana, what's my last step here?
Divide
Yep. By
4.
4. And 16 divided by 4 gives me how much?
You're asking me?
Yeah.
4.
4. Thank you. And that's it. That's the answer. X equals 4. So once you change it from a log form to exponential, it's all algebra 1 from here. Okay, very, very basic algebra 1. Any questions on that? All right, so in that one, you had your variable in the argument. Okay, the next one, the variables in the base. Still going to start out the same way. Get rid of that log. Very, very first thing you want to do. Okay, Alec, what's going to be my base here when I get rid of the log? X, good. X is the base. Okay, Riley, my exponent?
2.
Go ahead, yeah, go ahead, keep going. If you're with it, go ahead, you're rolling, keep going.
2.
X is 2. Exponent on X is 2. And what goes by itself on the other side?
64.
64. Now I'm going to ask Riley a question. All right, so now adding, subtracting, multiplying, and dividing, that won't work here. We got to get rid of squaring. So how do you undo squaring? Yeah, you're going to square root. Square root. Square root. All right, so Joe, what's the square root of 64?
No, that'd be
8. So 8 times 8 gives you 64. Now, negative 8 times negative 8 also gives you 64. But when we're dealing with logarithms, where's the original? You don't want the base to ever be negative, or the argument. It can't. Right? So technically, there's 2 answers when you take a square root, but because we're dealing with logs, you can ignore the negative answer. Try typing in a negative log on your calculator and watch what happens. It gives you an error. Okay. What does that mean? It's a non-real answer.
it's fake.
It's fake. It's a fake answer. Does non-real mean you can't do it? It's impossible to do? Like if I did something like this, that's impossible to do. It says you're not allowed to divide by 0. Calculation fails. But that gave me a different error. Yeah, it said that the answer is not a real number, it's an imaginary number. So if we were going to do imaginary numbers, we could do the log of -5. But we're not doing imaginaries. Right? So you never have to worry about the base of the argument being negative. And our last one. Okay, all the problems we've done so far, goal was to change it into exponential form. Can we change that into exponential form?
No,
No. Why not?
not allowed.
It's already an exponential.
Right, it already is. Okay. We already have something with a base, an exponent, and a number on the other side. So what else could we try?
Log form.
Yeah, try log form. Okay. Write it as a log, and maybe something will work out nice and cancel, and we can figure it out. Jalen, what's my base? Yep, E. Your base is always the thing that has the exponent above it. Base is E. Okay, Brianna, logarithm always equals what kind of number? Always equals the exponent, which in this case, 2x. Last thing, fill in your argument. Use the only number we haven't used yet, 5. Okay, anybody notice something there we've talked about today? Something that we can shorten up?
ln.
Yeah, what can you change to ln here?
Log
This. You don't have to, but it makes it look a little cleaner. Now your last step, to get x by itself, divide each side by 2. So x is the ln of 5 over 2. If they wanted you to round it off, this is how you type it in. Natural log of 5, make sure you close the parenthesis. Divide by 2. Anytime you're going to type something that comes after, you've got to close that parenthesis. That's the correct answer. 0.80. If you don't close the parenthesis, what it's going to do now is take the ln of 2.5. This is wrong. Okay. You forgot to close the parenthesis. 0.80. Okay, so there's the kind of the basics on logs. Tomorrow we'll learn how you can type in logs that have a base other than 10 or e. I'll show you how you type it in. And how you can combine logs together. Okay, it's kind of like combining like terms in Algebra 1. Okay, so the homework will be on 473. It's all evens. Everything is even. 10 to 16, 22 to 28, 34 to 38, and 92 to 98.